principal argument in polar form. In this lesson, we are going to discuss about principal arguments. Why we restrict ourselves to principal argument? Why not all arguments? I mean, all theta. Okay. So before that, I want you to try this question first. Is z is equals to -2 into cosine of alpha plus I sine of alpha a polar form? If not, how do you change to polar form? Pause the video and try. Okay, let's see. The answer is definitely no. Okay, no, it isn't. It isn't. It is not a polar form. Okay, polar form. What's not polar form? Because from the definition, from our definition, and the real part and imaginary part, okay, we have here this argument theta that start from positive real number. So this lies on the first quadrant. So we have y and x. So the complex number, polar form of this complex number x plus yi, is expressed as r, which is the distance from the origin to that complex number, or the radius, into cosine of alpha, okay, or in this case theta, plus I sine theta. This is the definition. All right, the first thing, r should always be positive. Okay, r should be always positive. Why? Because there is a distance. Okay, because there is a distance. Distance is always a positive quantity. The distance from the origin to this point, this one. So using Pythagoras theorem, we are going to square it. We'll never have a negative radius, a negative distance. Okay, negative absolute value. So we have to change it. So z is equals to -2 cosine of alpha plus I sine alpha. Okay, let's multiply this inside terms by a -1. So we have a positive r now. So we have negative cosine of alpha plus I sine of alpha. From the property, cosine of alpha minus pi is the same as, you have to prove it, cosine of alpha. The other one is sine. Sine alpha minus pi is the same as negative of sine alpha. Okay, so we can just directly substitute, instead of this negative sine and cosine, this one, which means twice of cosine of alpha minus pi plus sine alpha minus pi. Okay, now we have polar form of the previous non-polar form, okay, of complex number, unknown complex number. Okay, let's go to polar form for non-quadrantal arguments. Okay, in the previous lesson we have discussed polar form from the quadrant, but in this case we are going to discuss non-quadrant argument. Okay, so I want you to do some question here. Okay, let's discuss why principal argument, why we restrict our argument to principal only between pi and negative pi. So here is, okay, the coordinates. Okay, so we have here real part and the imaginary axis here. Okay, so look at this one. Assume we have a complex number which is x units away from the origin, okay, in a positive real axis, and y units in the direction of a positive imaginary axis. Okay, So this is the position of that complex number, okay, which is x plus x yi. Okay, so look at this one. If we have this theta, if it makes theta from the real part, from positive real axis, we have like multiple way to reach here. Let me use one here. Okay, I'm gonna start from this one. All right, it just go all around. That is 2 pi. All right, plus okay theta. Okay, plus theta. I have one option. All right, the second one, maybe I'm gonna start from this one. Okay, I'm gonna make it twice and reach here. Okay. This is another one. That's I just doubled this one. Okay, 4 pi plus theta. These all are complement terminal angles. They have the same terminal. But I have also another way to reach here. Okay, so let me start from this one. And instead of going anti-clockwise, I'm going to clockwise. All right, clockwise. Okay, 1. And then I have to have this theta in this direction. It's still the same. All right, it's still the same. The magnitude is the same. It's still theta. So whatsoever integral multiple of 2 pi, okay, integral multiple of 2 pi, and if we add theta, we will have the same value. We will have the same value as theta. This is the same as theta. This is the same as theta. Thank you for trigonometric. That makes, for example, 60 degree and 120 degree equal. It is a trigonometric function that makes this equal. All right, they have the same terminal. So there is a confusion then. The confusion. In order to use my principal, I mean my polar form, r, okay, cos theta plus I sine theta. All right, so what's my argument then? What's my argument? Which one should I take? That is a very confusing. To minimize this confusion, we are going to restrict, okay, restrict our value of theta. This is argument. It's not principal argument. So to change any argument to principal argument, okay, we have to, or that argument must be between minus pi and pi. It should be between these two, just to avoid the confusion. So having this in mind, let's do some problem. So let's see the argument of a complex number in different quadrants. Let's see, what if it is in the first quadrant? Okay, what's our complex number that is in the first quadrant? This one here, theta. Okay, this is x plus yi. Therefore, in this case, the argument, our argument must be, okay, argument of z must be tan inverse of just y over x. Okay, it just goes like x unit in the direction of the x-axis and y units up. So this will be the magnitude of our argand. Okay, so let's move on to the second quadrant. What if it is in the second quadrant? Okay, so real part and imaginary part. Okay, so if it is here, okay, this is, let it be, it just move x units, okay, x units along the negative part, okay, negative x, and y units above positive or along the positive real imaginary part. So this is our value here, y I. Therefore, in order to find this angle, okay, you see this angle, but the point is, here is our angle. Okay, here is our angle. So we need to find this. Okay, theta is tan inverse of y over x. Okay, this is argument. Argument doesn't mean the principal argument. Our argument theta is tan inverse of y over x. But the principal argument is this one. This is our principal argument. So in order to find that, okay, principal argument of z is, so you have to subtract from, there are two ways of course to consider here. Okay, let's see here. It should be tan inverse of, all right, tan inverse of y over x plus pi, or pi plus tan inverse of y over x. Why it is plus though? Why it is plus? Or another way, it can be pi minus from 180. If you subtract this angle, all right, you will find the other part. So pi minus tan inverse of y over x here. Okay, this is our principal argument. Now, when are we going to use positive, I mean plus? When are we going to use minus? It is the same thing, but the difference is, you should know the reason why we're adding, why we're subtracting. Okay, so you are going to add, if you just simply consider the value of theta, the tan inverse of y over x is negative, less than 0 if it is negative. And then in this case, you are going to take tan inverse of y over x must be positive, greater than 0. Let's see if it is in the third quadrant. Okay, if it is in the third quadrant, all right. So what we have is, let it be, it's here, okay, which means it goes x units along the negative real axis. This is the angle from this to this one. This is our argument. Okay, this is our argument. It's not a principal argument, but our principal argument will be this one. Okay, this one. This is our principal argument from positive real axis. This is our principal argument. So since the angle is more than 180 degrees, so to determine the principal argument of z, we have to use, we have to subtract from the angle, okay, from the argument pi. Okay, if it is in the third quadrant, this will be the magnitude or the value of the principal argument. Okay, now let's consider the fourth quadrant. Okay, let's see the fourth quadrant here. What will happen? So in the fourth quadrant, there is some exception. Let it be, it goes x units. Okay, it goes x units along the positive real axis and y units along the negative imaginary axis. So this is our complex number. So this is the angle, of course. This is our argument. Okay, this is our argument theta. It's not a principal argument again. So to find our argument, principal argument, this one is our principal argument. Okay, so if it is in the fourth quadrant, since we restricted our principal argument between minus pi and pi, okay, between these two, our principal argument in this case, argument of z will be tan inverse of y over x. Tan inverse of y over x. The point is, look, in this case, since it goes to anti-clockwise direction, here is the reason. Okay, since it goes to clockwise direction, our argument will be negative, right? Negative, because tan inverse of, okay, y is negative and x is positive. Since tan is an odd function, okay, odd function means it satisfies this condition. F of negative of theta is the same as negative of f of theta. Okay, this is the case, right? So this is one of theta tangent is one of odd functions, therefore it satisfies negative of tan inverse of y over x. Okay, therefore this is our argument. When you multiply by its direction, that's in the first quadrant, it becomes positive. That's the reason. Okay, that's the reason. This is argument, but the principal argument will be positive. Okay, this is the reason why we are using positive dot theta. Okay, let's summarize this. If the complex number lies on the first quadrant, so our principal argument will be just tan inverse of y over x. Okay, if it lies on the second quadrant, our principal argument will be pi, okay, plus, in short, just you don't have to be confused, y over x. Okay, but if it is in the third quadrant, our principal argument of that specific complex number will be pi, tan inverse of, okay, y over x. Okay, if it is in the first quadrant, our argument of z will be the same as if it is in the first quadrant. But the reason is, since it goes to in clockwise direction, that become negative, and then it is in the first quadrant, the value or the magnitude of the tan inverse of y over x negative, that will be cancelled out. So just keep this in your mind to calculate the polar form of a complex number.